What we noticed is that testing wasn't something that was a primary focus for the change. Like nobody was aiming at let's change testing, at least in our space, like in our developer focused testing. What happened really is there were external factors like this migration to clouds, migration to microservices, an exploding number of various databases that actually triggered this demand for better testing.
Hi everyone, and welcome to the Synthesized podcast. Today we are welcoming Sergei Egorov, who is the CEO and founder of AtomicJar, which are delivering test containers. Really looking forward to this one. We at Synthesized are actually using test containers for our internal development and really excited about exploring trends, challenges in software testing, software testing overall, how we help companies deliver better products to markets faster, how we enable companies adopt cloud, enable agile test data transformation, and how we can work together and bring this all to life. So really excited about this. Sergei is also a technical founder, so he previously spent about 10 years, I think, more than 10 years as a software engineer, and myself and Denis, who is joining this podcast, also a very technical founder. So really excited about this one and looking forward to it. So welcome to the podcast.
Hey folks, thanks for having me. I'm sure it will be an interesting one because we are at an intersection of two very similar topics, approaching it from various angles or from different angles. And yeah, looking forward to chatting with you, both of you, and let's see what we will discuss today. So I'm Sergei, originally from Russia. I've been living in Europe for almost 10 years and then moved to the United States. So now I'm broadcasting from New York City, Brooklyn, and I'm CEO of AtomicJar. And despite me having this management title, I was a developer my whole life. Turned from engineering into co-founder of a startup. And Testcontainers is the foundation for AtomicJar, and it's been there for 7 years as an open source project that allows making integration testing super easy by using Docker and by wrapping Docker with APIs that you can use directly from your code. And AtomicJar is the next step for test containers for the community and for the set of products, because we are now building Testcontainers Cloud, which is a hosted version that allows you running the same tasks, but not on your machine.
Cool. Yeah. Awesome. And Denis, do you want to also quickly introduce yourself and what we do at Synthesized?
Yeah, sure. I'm Denis. I'm the CTO and co-founder at Synthesized. My background is, software engineering, surprisingly. I've been doing it for the last 14 or 15 years, I would say. That was primarily backend engineering, like around Java stack, like microservices, Java, Scala, Kotlin, all that stuff. Spent several years in Germany. Then I finally moved to London to work on Synthesized. What is Synthesized? Synthesized is agile test data management for cloud era. So you can imagine Synthesized for test data is what GitLab or GitHub for like DevOps, basically. So we are building new generation kind of test data management tool.
Mm-hmm. Awesome. And I was particularly excited about this one because test containers and test data management are very complementary fields. So whenever we run tests, create test containers within those tests, we need to make sure we have some production data for some of the tests, for instance, for exploratory testing, for some other types of testing as well. And very excited about this podcast and the topics we're going to be discussing in the field of software testing. So guys, we all focused on making sure we can automate software testing process, or we can help QA engineers, we can help software developers, as Sergei does, do testing themselves as well. So what sort of core trends do you guys see in the market right now in software testing?
Mm-hmm. I apologize for this remark, but it's really just like not Sergei does, but like the whole team and like these folks are doing some magic, and I'm here just to make sure that they are all aligned. But I don't know. I think it's important to say. But regarding the trends, what we noticed is that testing wasn't something that was a primary focus for the change. Like nobody was aiming at let's change testing, at least in our space, like in our developer folks testing. What happened really is there were external factors like this migration to clouds, migration to microservices, an exploding number of various databases that actually triggered this demand for better testing. And also, I think if old school companies, the distribution of workforce wasn't really, like focused on just developers, as it is right now, more or less. Like everyone is developer. Like everyone tries to be a developer, and there is a lot of shift left movement. So let's make more things being done by developers. Old school style was like, okay, we have a major QA department, we have a major, development department, we have a major sysadmin or like sysops department. And now with this DevOps is, this famous thing about DevOps, like this infinity symbol. But what I see is that like everything happening everywhere, including testing, by the way, like it's here testing, here testing, here testing, here testing. Any stage of this is like testing is involved. And since there was a major shift in workforce towards developers, developers started dictating how they want to do testing. They don't want to start browsers. They don't want to, do exploratory testing. They are used to this process, but it's not the most efficient for them because what they want to do, they want to write code. And integration testing is somewhat a sweet spot because it gives much more confidence than unit testing, while also not as heavyweight as end-to-end testing that needs to be done in some environments, let's say.
Awesome.
Yeah, totally agree. So it's more like about global trends of agile transformation, cloud adoption, and DevOps. I guess maybe there is like even bigger or higher level trend is that we actually constantly learning how to ship software quicker. So that's, I guess, like the whole like shift that's been like happening over like last 20, 30 years. Like if you remember how software was developed like 20 years ago, like it's like release cycle, typically would be something around like maybe a year or even longer. So now we learn how to ship software like crazy, very frequently, but not all companies keeping up with that kind of. Some companies lagging because of number of reasons. They still have old school structure, and they're trying to kind of jump on this train of DevOps and CI/CD, basically. And something also that I think worth mentioning is that actually I think what we can see is decaying role of manual QA kind of. I think that's like what happens like almost everywhere. So like we want to ship faster. How we do that? Let's eliminate all kind of redundant stages in our kind of process. One of these stages like QA. Okay, how can we eliminate QA so we make our development cycle shorter?
And actually, I did notice growing popularity of ex-QA engineers, like brilliant engineers becoming brilliant engineers in general, like not just QA engineers, but, software engineers. And it was kind of nice to see. And I think like part of what you just described, like the elimination of manual QA, was almost triggered by QA folks themselves because they start automating more and more process. But at some point, someone else noticed that, okay, now that we have everything automated, why do we have a dedicated QA department? Why cannot just developers do the same? So it's kind of funny how it bounced back at them.
And maybe just touch on this one. I think we all agree that companies really want to build better products and ship them faster, shipping more frequently. What are the challenges for different companies to get there? So maybe we can touch on large enterprise clients and also maybe younger companies. What challenges do you guys currently see?
I believe like one of the challenges is the confidence, because if you have the confidence, then you're only limited by your tooling. Like if you're confident that your change will make it to production and not break everyone's system or like every user's experience, then you would be shipping like every time you can. So you would avoid, even continuous deployment. You would avoid it. You would do or continuous delivery. Like you would avoid it. You would do continuous deployment. Like okay, like every commit that goes into the main branch should eventually be automatically deployed to production environment. But then we hit the reality basically, because sometimes a single line, like changing a single line, especially in configuration, we all heard this famous stories about outages, even at the biggest tech companies in the world. Like AWS just brought down S3 a few months ago, or maybe half a year ago or something, by making a single line change. And imagine, I would have a PTSD if I was the person who made the change, because now I would be afraid to make a change to any line anywhere, and then I guess that would also trigger a lot of activities around gaining the confidence that okay, if I make this change, there is nothing that could go wrong, because I know that I have tests, I have monitoring, I have canary releases, so I can test it on a subset of users. And all of that comes with a lot of automation, because you cannot be confident in manual process, because manual processes are prone to human errors, and automated processes never lie as long as they're configured correctly.
Yeah, totally agree. Like I think confidence is also very much connected by other factor, which is called trust. So like it's pretty much the same thing, but confidence is like about like feeling about yourself, like how I'm confident about like pushing code somewhere to production. But there is like somewhat similar, but externally, like can organization trust you to do that? Unfortunately, that's like a problem in bigger organizations such as banks. So they really have this trust issue, to be honest. So
yeah, I think we see many companies understanding that they need to get there. So adopt cloud, enable agile test data management, but there are different ways to get there. So for some younger maybe companies, it's a little bit for scale-ups, for startups, it's just a little bit easier. But for more mature organizations with already arranged and established processes, it may take a little bit longer to get there. So to get to totally to shift left testing, it may take a little bit longer for them. So we don't really know how long, but there's definitely a move. There is definitely an intent to get there, but it just may take some time.
What is good and something we've seen with Nicolai together, even old school organization, they all want to jump on this kind of DevOps agile transformation train. They really want to. They not necessarily can now, and it's like long journey. But what is interesting, like even like quite conservative companies, like outside you would think, oh Jesus, they should be using mainframes, but they're trying to adopt like clouds, Docker containers and stuff like that.
Yeah, and last year I've seen reports that like cloud spendings by large enterprises has increased dramatically. Like people spend much more money on clouds nowadays, which kind of shows the growth in the cloud usage by these major enterprises, because otherwise, why would they spend money on it, right? I think that's the case for us as well, for our industry, is that we as DevTools companies, as software engineering boosters, we should focus on these weakest chains, because like, yes, we can move someone, we can move, someone fast moving, and then they'll go far. But then literally we cannot even, deprecate some features in our code unless we know that nobody is using them. But you know who will be using these features? Those legacy systems, those slow moving companies, those who are not ready to change. And it's kind of fun is when hipsters have to do something for like large enterprises, because it takes a lot of time to just understand your buyer and understand how they think about this. So it's good you brought it to this conversation, because that's really what we should focus on.
And by the way, just touching on the kind of large enterprises. So another very important problem is, which really prevents some of the companies to software testing in the cloud, is data. Because we know that many organizations still use on-premise data sources, databases, data warehouses. A lot of that is on-premise, and you want to make sure you adopt cloud, you adopt agile digital transformation, but it's hard. And it's very important to make it easy and work collaboratively on enabling companies to make it easier. So one of those elements is enabling companies to do software testing in the cloud is to use test data. And Sergei just wanted to maybe discuss this with you. Do you see demand for high quality test data, which can be used to create test cases eventually to run software testing? Do you see that across sort of your partners and clients?
We do see a lot of demand for test data providers because, and that's an interesting thing. Like, okay, we're shifting everything to the left, but what we cannot shift to the left, or what needs to be but still not shifted to the left, is QA mindset, like QA thinking. There are, of course, all these, anecdotes and stories about, QA entering bars and ordering 1 beer, ordering 10 beers, ordering -3 beers, ordering, I don't know, something with a floating point. And that's, wow, it's a joke, but this joke has very strong truth in it that a good task person, a good person who creates a task should have a pretty creative thinking, I would say. Like, it makes no sense if you're writing a calculator test 2 + 2 = 4, and that's what's in your requirements. Like, you would read your requirements for the product, you would see, okay, a calculator is something that gives you the result when you apply operation plus on two numbers. So, for example, 2 and 2, and scenarios 2 + 2 = 4. But that isn't really what should be tested. In fact, I would not even be testing that scenario. I mean, as the last one, like if you have capacity to cover, typical scenarios, then okay, but I would start with edge cases because that's the most interesting ones. And I guess this is where test data could also make a big play, because one thing is how you write your tests and how you prepare your test data, and integration test usually comes with test data next to the test. And this one is interesting because I still see it as a big advantage to be able to see your whole test scenario in a single place. While if test data comes as a snapshot from production, for example, then you have two sources of truth for your test, and then it's harder to follow them. On the other hand, this approach could actually bring this, okay, we never tested this scenario where someone was using our product for so long that they end up in this state. But thanks to the test data but generated, because I know a thing or two about Synthesized, but like, let's say test data generated from, the same patterns as seen in production could be a major advantage that will improve the testing. And maybe even, sorry, I apologize for a long one, but maybe even as something that can be plugged into, so that the same set of tests would be running with test data created by engineers to test their scenarios, but then sort of a mutation testing. Okay, yeah, that's the one I was looking for, mutation testing, because having this test data kind of allows us to have this kind of mutation, or not mutation, like more like property-based testing, actually. Like, let's just define how data comes in, and then it should pass with any type of data.
Yeah. I think it's also related to topic of exploratory testing. I guess this is what you were explaining by this mentality of basically hacking your software, being really creatively. Because I guess testing always has these two components, like system and creativity. Like for system, yes, you have automated tests, very structured, and so on and so far. But quite often people overlook this creative part. If you remember testing pyramid, so it's still pyramid. You still have this end-to-end testing on the top. If you think in very, very top, there is exploratory, creative testing. When you're thinking, okay, what is missing? After written all this tests, what else? And I guess when you have real data, it puts you in real conditions. You can see how application would work in practice, not in synthetic scenarios in your test, but how it would behave in practice. And it puts you in this mindset, okay, what if I was a user, how could I break it, and so on. I think that really helps to this process.
Yeah, I think it's a good point that for explorative tasks. I so rarely talk about this thing that I don't even know how to pronounce it. But like manual testing, let's call it like this. This is where having test data that is very close to real one is priceless, because one thing is your test where you can actually like insert a couple of lines into the database or a couple of entries, then assert what your endpoint returns. That one easy. But let's say we want to start the application and like code some endpoints and get a feeling of how it will look once deployed to production. Like we don't need to deploy it anywhere because we can do it locally with something like Testcontainers or just plain Docker or something. But the question remains, like how do we get the state that is close, or not like equal, but like very close or representative to our production environment, so that I'm not just calling some endpoints that return no data, but rather I return, or I get the results that look very, very similar to production. And then you start noticing that, okay, like your test never inserted more than 10 records to the database. And then apparently your database implicitly applies a limitation of, I don't know, like 10 records. And once you started doing this manual testing, you notice that, okay, apparently this endpoint always returns up to 10 records. And then I need to add a test that will cover this scenario that you weren't aware of before.
Yeah. Of course, it's important like to not kind of become lazy and just do manual testing by developers. I guess should be more like input for like writing actual tests. Like you explore and think about more scenarios, you find them and then you code them.
Well, actually, I'm pretty confident about that one, because that one of the questions we received when we were opening our company. Like, okay, like, and we were actually openly talking about the majority of testing at large enterprises is still manual testing. Like developers, they start service and then call some endpoints with some like HTTP or Insomnia or some other tools. Then like QA engineers are also doing the same. Like at best they have some Selenium automation, and like they were probing us because they knew the answer. But it's also important to understand the answer is that we talk about developers, very specific species of of software process, like people involved in software process. And what we know very well about developers, that developers are lazy. Okay, they will start the application once, 2 times, and next time they need to start it again and go through the same flow of opening login page, logging in, going to that page, then clicking 5 different buttons. They'll be like, why the hell am I spending time on this? Like, it would literally take me 5 minutes. And I know that there is a counter joke that like, why spending 5 times doing something manually if you can automate it in 5 days? And yes, that applies. Okay, I agree. On the other hand, it's recurring value, because next time, not only next time you don't need to perform the same actions, but next time you introduce a regression, it will catch the regression. And manual testing, unless you perform it recurringly, so nobody would do it really, won't catch it.
So maybe it's like too late. Like amount of technical debt is like it's enormous. They of course trying to automate, but you can imagine like if you're just starting after like decades of manual testing, it's a really big challenge for them. And this is also why, while we also kind of support the shift left movement overall and believe in like developer kind of involved in the testing and so on and so far, but in large enterprises quite often they will do still like a lot of manual testing, and manual testing where you need like prod-like data for sure.
And also, by the way, Denis, very importantly, I think not necessarily even prod-like data, but sometimes for performance and load testing, you just need to have much more volume. And if you have a new sort of service, a new application running, you may not have enough volume to just test against. And if it's a payment system and you need to launch it very soon, you basically need to test against some test cases and against some scenarios which may not even be available in the kind of prod data. So you kind of really need to think about how to automatically create interesting examples and make sure we make them available to software testers and even developers if you decide to move completely to the labs. In this framework.
So I think we all agree that there is no single type of testing that will cover everything. And as long as people use the right tools for the right type of testing and not try to load test with integration testing framework, or the other way around, not try to, like do some, I don't know, I've seen crazy things being done with the wrong tools. Like literally, like I sometimes seen some cool things being done with wrong tools, or maybe not wrong tools, but tools that never thought about them being used for that. Like, I know, for example, folks behind Apache Pulsar Stream Native, I know that they created chaos testing test suite for Apache Bookkeeper. Basically, it's a major component, the underlying component of Apache Pulsar with Testcontainers, because they can. Because they control the networks, they control the containers, they can just like, what happens if one of the nodes goes down? And then they can inspect everything. That was pretty cool. Not the usage Richard, the original creator of Testcontainers, created 7 years ago, and our CTO, not the usage he expected, to be honest. Neither I expected ever, but when they told us that, yeah, we're doing this, we're like, wait a second. Yes, you're doing what? With what? But that's a positive example, but there are so many negative examples when people do things that do not belong to the testing tool, including testing databases with mocking frameworks. Like, I don't know, modern applications, like 90% of them is basically, I don't know, code blocks with queries that just take data from one place, transform it, and return to another. And then unit testing this, like what would you unit test? That you generate string correctly? Well, that's your assumption that the string is correct, right? How will your database react to the string? And that's something that, I don't know, I feel painful about when people say that, like nobody needs integration testing, we just mock everything out. Well, seen that, done that, not gonna repeat any time anymore.
Well, that's interesting, Oliver, I guess, like this proportion of unit tests versus like integration tests. I also lean towards integration tests if they're good. And unit tests I find like most useful for complex logic, and for like things like you mentioned, like CRUD applications, it's just awful. I don't really see any value. Like I actually think for most of applications, which are like this, right? It just shifts SQL and JSON back. So for them, I think integration testing just enough. Kind of would cover everything.
At least it gives it covers 80% or maybe 90% of cases, and this is good because in terms of making your first investment, you always pick those that cover like the most cases. Like you would not be working on edge cases from day one. You would build. Let's say we think about this as building product. Let's say your test seed is your product. So how would you build your product? You would build your product for the majority of your users. And then you want to start getting value as soon as possible. So integration tests give you that. Like you just add a database, you write a couple of tests, and boom, your coverage is already at 80%. How come? Like with unit testing, you would be like, okay, I cover this method. Okay, it's plus 1% coverage. I cover that method. Okay, plus 2% of coverage or something like this. But with unit testing, just like the scope is so much bigger. And I'm not saying that it shouldn't have unit testing next to it. It actually should, because there are things that should really be unit tested and not integration tested. But on the other hand, it's a nice shortcut.
Yeah, also another factor, I guess, maintainability. Unit tests, they test on design, like by its idea, like whenever you change design of components or units, you need to change tests. Right? Like whenever you do refactoring, you need to change all your mocks, how components interact, etc. There is with integration tests, like which test just high-level specification. As long as you don't change the specification, the test like stays stable. You can refactor internals like as much as you can. I think it's also quite cool factor. Another interesting factor, I think it's somewhat related to testing. I think we discussed it during other podcasts. Somehow, like the new trend is usage of statically typed languages and all sort of linters, analyzers. That becomes also like a thing, like in testing. Like it's not testing necessarily, more like verification. Let's put this way, but that's also one of very common approaches. One trends I can see.
Yeah, I think it correlates very well with the common trend of faster feedback cycle, and sorry for off topic, but just like as a Java champion, I cannot not mention that the recent developments in the Java language has made it so much better in that regard, because now we have a lot of syntax support or like synthetic constructs that help us build better systems, like kind of pattern matching, where you no longer need to have like case classes, where you no longer need to have this default fallback to like throw not implemented or something. Like if I know that this is a set of classes I will ever receive, I want to actually see it in my code. And I don't want it to do, like, I don't want to check for it at runtime. I want my compiler to say that, hey, you forgot to handle this case. And we always had to make this balance between being memory efficient and being strongly typed. And sometimes we had to shift the balance towards memory efficiency, because otherwise you generate a lot of garbage in Java language. And that applies to Java, less to some other languages like Golang. But nevertheless, it's great to know that Java is catching up, because by removing weaknesses, bouncing back to the original conversation we had about enterprises, by removing weaknesses, you basically move the whole thing. And then, like, if you remove this weakness, then we'll align the baseline with all the great progress that was made in the Java world.
Yeah, that's probably like a vision of future, right? Like strongly typed languages, a lot of integration testing, end-to-end testing is minimized, no manual testing. A lot of component testing probably, and CI/CD, of course, with test data.
Yep.
And Sergei, by the way, in terms of AtomicJar and the work you guys are doing, we big fans first of all, and we of course we're actually using your product internally in the team, and it's been incredibly useful. Of course, we know that you're working with many other very huge customers in the US, UK, Europe. What are your key learnings from working with enterprise clients?
So first of all, we are in private beta right now, and I would not say that we have many other customers. Like, we have tens of customers right now that we are working closely with and making sure that the product, like once we release it later this year, it will be solid, and then that's part of the private beta process, really. So I'll be focusing on this one. But we did get some interesting learnings from the private beta users, and some of them, of course, they just verified our assumptions about our product and our go-to-market strategy, and others, and just an overall product market fit. We start with ideas that running test containers without Docker locally available can be a great advantage, because not only it helps with security, with speed of execution, but also it gives you back all these resources you previously had to give to Docker. And I know that a lot of folks aren't feeling happy about having to give 8 gigs of RAM to Docker, and then how do I run Slack and Chrome, right? You need to Slack, Chrome, Docker, pick 2. So with Testcontainers Cloud, it's basically possible. But what we learned once we gave the thing to the users is that, so for example, we were always under assumption that speed is one of the most important things, because we all talk about speed of delivery. But then it comes with the realization that it matters, or it depends rather, because does it really matter if it's 1 second or 2? Probably not, unless it's multiplied by 10,000, right? But then does it matter if it's 5 minutes or 15 minutes for total time? It does, actually, because these are different, brackets, basically. But one underappreciated thing is responsiveness. And I did notice responsiveness being a priority before with IntelliJ, actually, where IntelliJ is an awesome IDE. I love IntelliJ, I really do, despite some, hearing from me.
Like Vim and VS Code and this kind of stuff.
Yeah.
They're not that powerful, but they just responding,
It is the best IDE. But then with being the best comes also some, moments about it. For example, indexing, which is a necessary step in your development process. And once indexed, you can do crazy things with your code. This is what differentiates IntelliJ from VS Code, for example, despite them having some Java support. but it's nowhere close to IntelliJ, obviously. But then me as a developer, okay, if I need to index it once per week or something, then I mean, I'm fine. Like, waiting for 10 minutes once per week, I think it's fine. But when you start noticing indexing being a regular thing, when you switch branches, for example, what I would be fine with is if my system remains responsible. So, okay, there is some background indexing. I might need to wait longer, or I might just use some reducted functionality in IDE unless it's indexed. But I would still continue using my computer. And also, IntelliJ isn't the only thing that runs on my computer. I need to switch to some some browsers, Slack, once again, and other windows. And if one of the applications takes 100% of resources, then I focus on that application. And sorry for a long one, but when it comes to running tasks, I realized that, okay, integration task is also source of this being like a single source of 100% consumption. And since our product allows moving workloads to the cloud, basically to the edge, to be more precise, is that you no longer feel, because you no longer need to allocate these resources, the CPU, this RAM, while running the task. And you realize that, okay, now I can do more things. I can, research some topic while the tests are running, if they're long running, or maybe I can even run them in parallel, because now I can, because previously I couldn't, because my resources were already allocated to, dedicated to containers.
Yeah, that's cool. Just curious. Don't you work on some database optimization for containers? I guess this is also one of bottlenecks that it's quite fast to start something in test container. But what if you can make it even faster? Optimize somehow, hack database. It's even faster, for test purposes.
So what we do, we do a lot of research. I think Testcontainers team is one of the teams that knows almost the most about many databases out there when it comes to dev experience. Something that isn't obvious when you look at it, but then you start realizing that, okay, we do know how to optimize certain databases, how to start them fast and everything by using some internal APIs, and we work closely with vendors. In fact, now that we have an entity behind the project, not just open source project, but a real business, real entity, we are establishing more and more partnerships with database vendors, and they're very eager to collaborate, and they take our word as basically as given when we say that, okay, this is what can be optimized in your database, and then they skip this part of whether it's needed, because they know that in Testcontainers community there's a lot of demand, but they see how Testcontainers community are using their databases. And then we sometimes go, we dig into database internals for further optimization. So for example, Kafka module, which is one of the most advanced modules in Testcontainers, it is it has a lot of optimizations. We also know a lot how Kafka protocol works, so that Testcontainers is basically the only solution out there for running Docker or Kafka Docker image on random port. You cannot do it with Docker Compose. There aren't many other solutions for that. But our model of how we define modules allows us to do that. And there is obviously an advantage of running things on random ports, because you're no longer getting conflicts when you run multiple things in parallel, especially on the same CI machine. But back to the point of us, we aren't contributing fixes, let's say, or improvements to the database, at least not yet. We actually prefer to collaborate with database vendors who know better how to make these changes. But what we do, we give them basically this intel about what's slow. So we can go to someone and say, hey, we have this module and we notice that it takes 3 seconds to initialize or pre-allocate file system. But for tasks, you don't need file system. You can do it in memory. So could you please introduce some flag, some environment variable to make it in memory? And say oh yes, it's no brainer. It's the one interface to implement. And boom, then they release it, and then containers start, 3 seconds faster. And last but not least, we also realize that some technologies sometimes are just impossible to optimize like that. And let's say Oracle starts tens of seconds, because that's a major database. It's a big database from I don't know when Oracle got created, like 90s, probably 80s, maybe
1995,
yeah,
probably.
Yeah, I think like 90s, and it's not easy to just boom change the database, introduce in memory storage and everything. Like you literally need to initialize it, and like there's a lot of things involved. DB2 is the same thing. Like actually DB2 requires some privileges to reconfigure the system it runs inside. So it's not just process, it's actually part of your operation system, your Linux operation system. And for that ones, we are trying to be creative where, okay, but what if we don't need to start it every time? Like we could literally capture the state and either reuse an existing instance or maybe be a bit more creative with some advanced containerization technologies, because our foundation, Docker containers, gives us the abstraction. And then with that abstraction, we can, for example, freeze and unfreeze basically any container, right? So there is a lot of potential for that. And we work in both ways. Collaboration with vendors and skipping the overhead of startup altogether.
Cool. Sergei, what's the next big thing for you and the team you're really excited about?
Public beta. I guess that's
the two.
Yeah. But really, like all the focus right now is on public beta. But obviously, once we release it, and once we have first, happy customers who came in through, like self-service and everything, which will be a major milestone, of course, for us. We really want to explore options now that we control the environment where test containers are running. We can do a lot of things. I already mentioned this, like checkpoint restore, CRIU as well, which is a technology that didn't get a lot of adoption because it really requires, like back then, it required some kernel patches to be applied if you want to run it. And obviously for test containers, open source users, as much as we wanted, because it hurts seeing users reporting that, okay, like containers takes long to start, and like this is why the responsiveness of tasks isn't that good. Like we always optimize, we always find ways, but sometimes we simply cannot. And with now that we control this environment, in our controlled environments, we can do crazy things because we are optimizing for specific use case, up to being able to, apply patches to Docker and then removing parts that would make sense for stateful workloads, for long-running workloads, for example, but for testing, they only add overhead. All of that we can do now that we control it. And this makes me very excited because I know that there is so much else we can do. And we literally, like every now and then, while talking about future test containers features, we're like, I wish we could kind of have our own Docker so that we can do things with it. But now, well, why not?
Thank you, Sergei, for this incredibly insightful conversation. It's been really great to discuss challenges and trends in software testing, how we can enable companies to ship better products and services faster, how we can enable shift left, but also in a gentle way, supporting sometimes still manual testing and supporting some of the enterprise clients as well, and helping them adopt cloud faster, helping our collaborate to learn this. The need for test containers is very clear, and looking forward to the next phase of AtomicJar and working very closely with the company as well. So huge fans, and thank you a lot, Sergei, for joining the session. Thank you.